Hello folks, today we're going to work on kissing moles, which is your 35s. We're going to go through the problems and make sure you're ready to go with how to do these kinds of problems. On this page I want to point out this part. It says note that 6.02 times 10 to the 23rd has 3 significant digits. Alright, so just like before, H2O is a molecule. And H2O is made up of 2 atoms of hydrogen and 1 atom of oxygen. This is where it gets a little bit more important because we're going to actually use this kind of information today. So in 1 mole of water molecules, there would be 2 moles of hydrogen atoms and 1 mole of oxygen atoms. So now we're talking about subscripts, and they can be read as mole ratios, and those would have infinite number of significant digits. So that's kind of important as we go through today. We're going to be using this information on a lot of the problems. So on this particular problem, it is telling us that we have atoms of sulfur and we want to go 2 moles. So we're going to start off over here and we're going to end up over here. We're going to have to go across that bridge, which is 6.02 times 10 to the 23rd. And remember, every bridge is a multiplication sign. So this problem should be fairly simple, maybe 1 multiplication sign in this problem. So we start off with what they give us, 3.01 times 10 to the 23rd atoms of sulfur. We always start with what they give us in the label. The next step is a multiplication sign and a division bar. Remember, whatever label is on top of the previous step goes on the bottom of the next step. So we put atoms of sulfur right there. If we go back and we look at that mole map, we're right here. And we want to go this direction to moles. And since there is a bridge there, we can do it in 1 step. So from atoms of sulfur, we can go to moles of sulfur. We just went across 6.02 times 10 to the 23rd bridge. So 6.02 times 10 to the 23rd needs to go with one of these 2 labels. So what I kind of want you to just kind of always get in your head is that 6.02 times 10 to the 23rd is what we call 1 mole. You'll never have 6.02 times 10 to the 23rd moles. So try to resist putting this with the mole label. So we want to put here a 6.02 times 10 to the 23rd goes down here, and that is 1 mole. We go through, atoms of sulfur cancel there with there. We're left with our answer in moles of sulfur. And we end up getting, when we punch that into a calculator, 0.500, even though your calculator probably stops after 0.5 moles of sulfur. Here we have 3 sig figs. Here we have infinite sig figs, and here we have 3 sig figs, so our answer needs to have 3 sig figs. Stop the video, take a look at that, and see if you have any questions. And we're going to pop into the next problem at this point in time. Number 5. It says, how many nitrogen atoms are in 2 moles of nitrogen gas, which is a diatomic element? Well, the first thing we need to understand is that nitrogen gas is N2. In this problem, we're going to start off with 2 moles of nitrogen gas. So we're going to start off right here, and that's going to be of N2. And we're going to have to get to atoms of nitrogen. Well, atoms of nitrogen are different substance. So we're going to end up going down to this mole down here, but this is going to be of just N. So when we change substances, we end up using this bridge that's between the two moles. This bridge is already on your paper, but you can write it in if you need to on your cover. This is called subscript bridge. And we're going to have an infinite number of sig figs when we use subscript bridge. And then finally, we want to get to atoms of nitrogen. So we're going to end up going this direction and end up over here. So if we do this problem, we should have one multiplication sign and two multiplication signs, and we should be where we need to be. So to solve this problem, we start with what they give us, 2.0 moles of N2. We put the multiplication sign, division bar. Whatever's up here in this step goes on the bottom of the next step. We go to moles of N2. Now we're going between the heart and the other heart. And that's where we use subscripts. So we can go from moles to moles. So here we're going to go to moles of N. We don't want our answer in moles of N. We want it in nitrogen atoms. So we have to get rid of that label. So that goes on the bottom of the next step. Moles of N. And now we're going to go from this heart over to atoms of N. So if you're looking on your mole map, you can kind of see the pathway that we went. So we can go to atoms of N. Now we go back and we're going to put in some numbers. So mole to mole, that's subscript bridge, which is right there. So we look at the subscripts. There are 2 nitrogens in every 1 and 2. There are 2 moles of nitrogen in 1 mole of N2. Now we go over to the next one. It's atoms and moles. So that's 6.02 times 10 to the 23rd is going to come in. Again, that number should never go with the mole label. So 6.02 times 10 to the 23rd atoms are in 1 mole. You look at our labels, this label cancels out with this label cancels out with this label, and we're left with atoms of nitrogen. Now you punch all that into your calculator, and you're going to get 2.408 times 10 to the 24th atoms of nitrogen. But sig fig-wise, we got to go take a look and make sure we have the correct number of sig figs. Right here we have 2 sig figs. Here we have infinite. Here we have infinite. Here we have infinite. And here we have 3 sig figs. So our answer can only have 2 sig figs. So this would be 2.4 times 10 to the 24th atoms of nitrogen. The backside is your homework for tomorrow. Good luck and come on in for help if you need it.